Assalamu alaikum wa rahmatullahi wa barakatuh. In the previous lecture, we talked about the tractor and tractor component, tractor classification. Uh, the most important component of tractor is the internal or its internal combustion engine, diesel engine or auto engine. So, in this lecture, we are going to talk about the internal combustion engine. Before Before we talk about the internal combustion engine, we need to know what is heat engine. The heat engine is a device convert a thermal energy into mechanical work or mechanical energy. So the heat engine convert the thermal energy, heat, the thermal energy is the heat, to mechanical work or mechanical energy. Something like steam engine, diesel engine or gasoline engine, all these are examples for the heat engine. Heat engine can be classified according to the contact between the working fluid and the combustion product into uh, two types: internal combustion engine and external combustion engine. Internal combustion engine is the combustion process happen inside the cylinders, so the working fluid will be in contact with the combustion product. The external combustion engine, the working fluid will not be in contact with the working fluid. The working fluid won't be in contact with the combustion product. So we can say that the external combustion engines, the combustion process happened outside the engine cylinder, outside. That's why it's called external, outside the engine cylinder, and so on. The working fluid doesn't come in contact with the combustion product. Examples for external combustion engine: steam engine. In this video, we will see the external combustion engine.
How do steam locomotives work? With the invention of the commercial steam engine of itself,
We can use fuel, coal, coke, wood, oil as a fuel for external combustion engines. We will need water and fuel.
or in a tender pulled behind. The fuel is used to run a fire inside the engine, burning inside what's called the firebox. The fire is managed by the fireman in the cab, who, along with the driver, is needed to run the steam locomotive. The firebox sucks air from underneath the train to keep the fire from starting. The solid fuel sits on top of grates, through which dead ash can fall down into the ash pan. The firebox allows heat and smoke to escape the chamber through the so-called fire tubes, running the length of the boiler.
So now we put the fuel here, and the combustion process happened. The heat will go through these tubes. The heat will be transferred to the water inside the boiler, so the water will be heated up.
The boiler wraps around the firebox and fire tubes, thus heating the water inside to boiling point, creating steam. As more and more water evaporates, steam builds up inside the boiler, creating pressure. Inside the steam dome, the steam can find a way out of the boiler towards the cylinders.
Now the water comes hot and turn from the liquid transform into the gas form. Steam will go through this main steam pipe to the external combustion engine.
As the pressure becomes too high and the boiler risks exploding, the safety valve pops to relieve pressure. The amount of steam exiting the boiler is controlled using the regulator valve. This is effectively on to the cylinders. We get to the part that actually drives the wheels. There are two sets of cylinders, one set on each side of the train. Each set has one cylinder with a piston.
In this cylinder, we have a cylinder,
which in
piston,
turn is connected to
a
the
driving rod,
wheel, which can be connected to the other
the
wheels.
driving wheel.
The other
How this
cylinder
engine
contains
work
the
or
slide
how
valve,
the cylinder moves?
which allows fresh steam
We have
to
a
enter,
slide valve.
used to
This valve will control where the fluid or the working fluid, which will be the steam, go. If the steam comes from the main pipe into this path, so it will push the cylinder in this way. If the steam comes to this path, so it will force the piston to return or to go in this way. So uh, which control the way or the path which will the steam goes through this valve, which called slide valve. So we have a slide valve here. This slide valve will control the steam path and also control uh, the exhaust or the exit of the used steam. Steam comes from this path, will the pressure will force the piston to move, and we need to get rid of the steam in this side. It will go through the slide valve to the exhaust.
exhaust from the piston cylinder. This way, the piston is pushed once.
Now the slide goes in the next position, allowing the steam to go through the front of the cylinder,
from both sides to complete one rotation, creating
and
that
so on.
reciprocating motion, which is then used to rotate the drive
Reciprocating
wheel.
movement.
Steam, now done with its job, exits towards the smoke box, where it joins any smoke coming off the firebox to a
The other type of the heat engine is the internal combustion engine. Internal, which means the combustion process will happen inside the cylinder itself, and this means the working fluid will be in contact with the exhaust or combustion product. Internal inside. Petrol engine and diesel engine are examples for internal combustion engine. The petrol engine, the working fluid is a mixture of air and fuel. The diesel engine, which is another example for internal combustion engine, the working fluid also is a mixture between air and diesel. So how the internal combustion engine work? First of all, the combustion process need oxygen. So the air, which will be the source of oxygen, is drawn into the cylinder. Next, we need to the combustion process to happen. We need a fuel, so we need a quantity of a fuel introduced into the engine. This process will be different from diesel engine and petrol engine. In petrol engine, a mixture of air and fuel uh, goes out drawn into the cylinder, uh, while in the diesel engine we need a pump, and uh, we need to inject the fuel inside the cylinder. Then we need to make a mixture of air and fuel, and then this air fuel mixture is compressed. The compression process will heat up this mixture. There is a relation between and pressure and temperature. If a pressure goes up, the temperature goes up. So this compression process will heat this mixture. Then the air fuel mixture, or the fuel air mixture, is ignited even by a spark plug in petrol engine, in petrol engine, or by the heat of compression. As we said before, we will compress the mixture, and this compression process will heat up this mixture till it achieve or the self burning temperature, so it will ignite, or the combustion will happen through the heat of compression, and this will happen in diesel engine. Um, After the combustion process happened, we need uh, to get rid of the exhaust or the combustion product. So the burning of the fuel air mixture causes a rapid rise of temperature, uh, which cause a rapid rise in pressure, which act against the piston, producing a force on the piston. Uh, we use a crankshaft to convert and a connecting rod to convert the linear movement of the piston to a rotary motion. So the connecting rod and the crankshaft use for converting the linear movement or reciprocating movement into a rotary uh, motion. The product of the combustion are expelled or rejected from the engine. Uh, all combustion engines will go through the 8 stages we mentioned in the previous slides. Uh, the different will be how they do these stages. So as we said before, we have the fuel. The fuel have a thermal energy. This fuel will uh, mixed with air to make the combustion. The combustion process will generate heat or more heat. This heat will uh, make the gas to expand. This gas expansion process will produce a pressure. This increase of the pressure, we said, as we mentioned before, pressure equal force over area. So if we have a cylinder, and this cylinder contain a piston, and then this the combustion process happened in combustion chamber in this place. The pressure will increase here, then it will act or force the piston to goes down. No, it's not so. This force will make the piston move in a linear move or reciprocating move, using the crankshaft to convert the linear movement into a rotational motion, uh, which will be our final product as a mechanical energy. We have two kind of internal combustion engine. The first type is the four-stroke engine, the four-stroke cycle. In this case, we have uh, let's see how the 8 requirement mentioned before will happen in this type, the four-stroke cycle. First, here in this image, we can see we have 4 strokes. For the first stroke called the intake stroke. The intake stroke uh, red. Okay, and we have here the cylinder, the piston, and intake valve, exhaust valve, intake valve, exhaust valve, piston, and cylinder. The piston moves between 2 points. The first point here, or the lowest point, called the bottom dead center. The bottom dead center, which is the lowest point the piston reach. The piston won't go down this point. The higher point is called the top dead center, which will be the highest point the piston can reach. So the piston moves between those two points in a reciprocating or a linear movement. In the first stroke, the piston will go down and the intake valve is opened, so the air or the air fuel mixture will get inside the cylinder. If we have a petrol engine or gasoline, petrol or a gasoline engine, the air fuel mixture will introduced into the cylinder. While if it's a diesel engine, in this case, just air go through the cylinder. This called the intake stroke. The second stroke is the compression stroke. So we need to compress the air, or we need to in this engine case, or we need to compress the air fuel mixture if we have a petrol or a gasoline engine. So the piston will move up from the bottom dead center to the top dead center, and both intake valve and exhaust valve, intake valve, exhaust valve are closed, and in this case the air or the air fuel mixture will compressed in this place, which called a combustion chamber. After the compression process happened, uh, the the third stroke will called the power stroke or the expansion stroke. In this case, we need the ignition to happen. We need the combustion to happen. Uh, the combustion process happened even by a spark plug in spark ignition engine. In spark ignition engine, the ignition happened by electric or electrical spark by this spark plug. This called spark plug بوجيه أو شمعة احتراق. The spark plug will generate electric spark. The electric spark will burn the air fuel mixture in the gasoline engine. If we have a diesel engine, the spark plug will be replaced with a fuel injector. As we mentioned before, in the diesel engine, we just sucked air, so we compressed the air. We still don't have any fuel, so the fuel injector will inject the fuel into the heated air. Then the combustion will happen. So either by the spark plug or the compression, which called the compression ignition engine, by the heat of the compression, the combustion will happen. This combustion will increase the temperature and will make this air fuel mixture expand. This expansion or the expansion process will cause the force which drives this piston down towards the bottom dead center, and this is the useful stroke in the engine. Then we need to get rid of the combustion product, so the last stroke will called exhaust stroke. The exhaust valve will open and the piston will move up from the bottom dead center into to the top dead center, forcing the combustion product to get out the cylinder.
Today, the internal combustion engine is used in motorcycles, automobiles, boats, trucks, aircraft, ships, heavy-duty machinery and power generators. A four-stroke engine is an internal combustion engine in which the piston completes four separate strokes: intake, compression, power, and exhaust during two separate revolutions of the engine's crankshaft, and one single thermodynamic cycle. Let's take a look at the basic internal parts of a four-stroke engine. Inside the engine block, there is a crankshaft. Piston rods are attached to crankshaft. Pistons are attached to the piston's rods. As the crankshaft turns, it causes the lifter to make each piston move up and down. At the top of the crankshaft there is a camshaft which is connected to the crankshaft by a timing belt. While the crankshaft is making the pistons move up and down, the camshaft is turning, making the valves to open and close. Let's now take a look at how the combustion creates pistons motion. First, intake stroke. The inlet valve is opened, and the fuel-air mixture is drawn in, as the piston travels down. Second, compression stroke. The inlet valve is closed, and the piston travels back up the cylinder, compressing the fuel-air mixture. Just before piston reaches the top of its compression stroke, a spark plug emits a spark, to combust the fuel-air mixture. Third, combustion stroke. The piston is now forced down by the pressure wave of the combustion of the fuel-air mixture. The engine's power is derived from this cycle. Fourth, exhaust stroke. The exhaust valve is opened, and the piston travels back up, expelling the exhaust gases through the exhaust valve. At the top of the stroke, the exhaust valve is closed. This process is repeated. What had been presented is the cycle of operation of one cylinder of a four-stroke engine. Generally, engines have two or more cylinders acting in concert with each other to produce the engine power.
So, the difference between the spark ignition engine and the compression ignition engine will be like, in the spark ignition we need spark plug to make this spark, the electric spark. In the compression ignition engine, the spark will be replaced with the fuel injector to inject the fuel to the air. In the spark plug, in the spark ignition engine, we will suck just or a mixture of air fuel into the cylinder in intake stroke. In the diesel engine or in the compression ignition engine, we will suck just air. So we use gasoline or petrol in spark ignition engine. We use the diesel fuel in the diesel engine or in the compression ignition engine. The cycle of the spark plug engine called the Otto cycle. The cycle of the diesel engine called diesel cycle. In the diesel engine, as we said, we have four strokes: intake stroke, compression stroke, power stroke, exhaust stroke. In the intake valve open, the air introduced into the cylinder, while the piston moves down from the top dead center to the bottom dead center. In the compression process, the piston will goes up from the bottom dead center to the top dead center, compressing the air, while the both intake and exhaust valve are closed. Then the fuel injector will inject the fuel to the heated air. The fuel will self-ignite because of the high temperature of the air. The combustion process will expand this air fuel mixture will and force the piston to goes down. In the last stroke, the exhaust stroke, the piston will goes up and the exhaust valve is open, and the exhaust or the combustion product spilled out of the engine cylinder.
An internal combustion engine transforms the chemical energy in fuel to mechanical energy. Diesel engines, which have been serving mankind for over a century, are the most versatile and economical IC engines. To release the chemical energy in diesel effectively, an atomized form of the fuel is made to contact with high temperature and high pressure air. This energy is effectively transferred as mechanical rotational energy. So the operation of a diesel engine is all about producing high temperature and high pressure air continuously. We will see how this is achieved in this video. Piston, connecting rod, crank, and cylinder form a mechanism called slider crank mechanism. Here, the linear motion of the piston is transformed to a rotary motion at the crank. In an IC engine, this mechanism is properly supported in an engine block. Cylinder head, valves, and fuel injector are fitted above the engine block. When the piston moves downwards, inlet valves open and fresh air from outside is sucked in, or, in other words, the engine breathes. During the return stroke, inlet and exhaust valves are closed, and the air inside the cylinder gets compressed. During the compression stroke, the piston does work on the air, so the temperature and pressure of the air will rise to a level which is higher than the self-ignition value of the diesel. An atomized form of diesel is injected into this compressed air. The fuel gets evaporated and undergoes an uncontrolled spontaneous explosion. As a result, the pressure and temperature rise to high-level values. The high-energy fluid pushes the piston downwards. The hot air does work on the piston, and energy in the fluid is converted to the mechanical energy of the piston. This is the only stroke where the piston absorbs power from the fluid. Due to inertia of the system, the piston moves upwards again. This time, the exhaust valves open and the exhaust is rejected. Again, the suction stroke happens. This cycle, which has a total 4 strokes, is repeated over and over for continuous power production. You may have noticed that a bowl is provided on top of the diesel engine piston. During the compression stroke, this bowl helps produce air that is rapidly swirling. Thus, the injected fuel gets mixed with the air effectively. The mechanical design of IC engines, particularly that of diesel engines, is a challenging and interesting task. Since the combustion process in diesel engines is never uniform and smooth, they are prone to more vibration and noise compared to petrol engines. Thus, diesel engines require a rugged structural design. Out of the 4 strokes, it is only during the power stroke that a tremendous amount of force is exerted on the piston. So a single-cylinder engine will always have high force non-uniformity as shown. Similarly, the output power will also have a fluctuating nature. But with more number of cylinders, one can overcome these problems. Consider this 4-cylinder engine. Here, 4 different strokes can occur at a time. So the power stroke is always present in the engine. As a result, a 4-cylinder engine will have better force and power uniformity. In short, the more cylinders an engine has, the smoother it will operate. A 4-cylinder engine generally operates on the following firing order. A heavy flywheel which acts like a power reservoir further helps in smoothing out non-uniformity of power. A huge unbalanced force arises in the form of dynamic unbalance due to the excessive mass at the connecting rod side. This is negated by providing counterweights on the crank side. Opening and closing of valves are accurately controlled by a pair of camshafts. Camshafts derive motion from the engine. It is clear that the camshafts need to rotate at half the speed of crankshaft. We hope you had a nice introduction on the working of diesel engines. Thank you.